So we know I2P here, we know I2A here. So the distance AP will be equal to AI2 minus PI2. This will be equal to RA, the addendum circle of the wheel square minus R cos xi, the pitch circle diameter, pitch circle radius of the wheel R cos xi. Xi is angle between line of force, line of pressure, and common tangent to pitch circles. Pi2 is equal to R sin xi. From the similar derivation, you will get Bp equal to Bi1 minus Pi1. So I1P is again equal to small r sin xi. This is a triangle with xi angle. So I1P is r sin xi, and I1B will be determined by creating a triangle connecting O1 and B, and then we know the base and we know the hypotenuse. Hypotenuse is equal to RA, the addendum circle radius for the pinion, and the base is O1I1. O1I1 is known, that is equal to R, the pitch circle radius cos xi. So hence Bi1, it will be equal to hypotenuse square RA, addendum circle, minus base square, so small r cos xi square minus Pi1. Pi1 is nothing but small r sin xi. So you can see that both the expressions are similar for AP and BP. The triangles are almost same, and for one is for the wheel and another is for pinion. So the total distance of path of contact AB is equal to AP plus BP. So this is equal to capital RA square minus R cos xi whole square plus minus R sin xi plus small ra square minus small r cos xi square minus small r sin xi. So expressed in terms of the radius of addendum circles, capital RA, small ra, radius of pitch circles, small r and capital R, and the pressure angle, the angle between the, this is called pressure angle, angle xi, that is the angle between pressure line and common tangent to the pitch circles. So with these three quantities, we can determine the path of contact. More than the path of contact, which is a linear distance along the pressure line. So A and B, this is a linear distance. So this is called a path of contact. More than that, we are interested in the arc of contact. So by that arc of contact, we can get the angular rotation, angular displacement for which the teeth engagement takes place, and from that we can get the contact ratio used in the calculation of contact ratio that we defined earlier as arc of contact divided by circular pitch. This will give the number of teeth in engagement at a time instant and help to calculate the loading on the teeth. That's why arc of contact is more important to calculate. We will draw a diagram here for this calculation. So this is the point where the engagement takes place first. This is the point P at the center, and this is the last point of contact, that is point P. Now we will have the wheel's pitch circle passing through the pitch point P. We'll draw it here like this. So let's say the teeth cuts the pitch circle the engaging position for position A. For the point P, anyway, is P only, where it cuts the pitch circle. So why we are using the pitch circle, because in all the derivations of arcs, arc of contact, circular pitch, we have to use the pitch circle. Because with that, whatever angular displacement we get, we can directly use it for velocity ratio conversion. That's why you have to work with the circular, with the pitch circle. This point E, this teeth will have a base somewhere here. Let's say the base point is M, and in this position the base point is N. So we want to derive the relation between EP. EP will be our arc of contact for the time period from engagement to the center point, and then PB will be for the recession point. So we'll draw a triangle EP and connecting to O2, which is the center of the wheel. And again we'll draw a triangle connecting M to O2 and N to O2. So since the relative angular position of wheel cannot change, EM and NP is basically the same line, the same profile on the gear at different time instances. So hence if some angle has been moved from E to P, whatever angle has to be moved, the same angle has been moved by M to N. So hence angle MO2N is equal to angle EO2P, because basically the same profile on the teeth, that is traveling. So it can travel in same angular displacement. Now from the geometry we know that the arc lies on the base circle. So base circle is determined by drawing a perpendicular from O2 on the pressure line. So in all derivations, whenever we talk about base of the teeth, it is a base circle, not the redundant circle. Redundant circle is a spatial gap, that is the clearance left between the teeth to avoid interference. But for normal gear derivation, we will not consider the redundant circle. The base circle is formed by dropping a right perpendicular on the pressure line. So this is a pressure line, and we'll drop I2, and then using O2 I2 will draw a circle. This will form a base circle. So from this triangle we know that O2P is equal to R, the pitch radius, and this angle is xi, the angle between the between the tangent to the pitch circle and the pressure line, xi. Since this is xi, this will be 90 minus xi, and since this is 90 degree, so this will be xi. Simple derivation. So the distance O2 I2 will be equal to R for xi. So the radius of the base circle is same. So M and N lie on base circle. That is the starting we did the derivation circle. So hence O2M is equal to O2N is equal to O2I2 base circle radius, that is equal to R cos xi. So now the angle MO2N L is equal to R theta. You know this identity. So hence theta will be equal to arc length divided by radius. So arc length we want to consider MN, and the radius is R cos theta, that is O2M. So this will be equal to angle MO2N. Similarly, in this triangle, the angle EO2P will be equal to arc EP, this arc, divided by the radius. Radius is R. So angle EO2P is equal to EP by R, and angle MO2N is equal to Mn by r cos theta. We saw in the earlier quantity that MO2N and EO2P is same because the same gear profile is traveling. Hence, equating these two quantities, we get finally Mn by r cos xi, the pressure angle, is equal to EP by R. The R gets cancelled out, and hence R EP is equal to R Mn divided by cos xi. But now we will invoke a special property of the involute profile. From the involute profile, we know that the arc Mn is equal to line AP. So I explained you earlier about the unrolling of the thread of the spool. So let's say the thread is on the spool, the thread is Mn, it is lying here, Mn. So when you are unwrapping the thread, you will make the involute profile, and in the process you will have a straight line AP. So from involute profile condition, Rmn is equal to line AP. So line AP, we know that is the first half of path of contact. So thus the arc EP, which is arc of contact, is equal to line AP divided by cos xi. Thus, using the involute condition, we know that R of contact, the similar derivation can be done for the other half also, for the I1 region, for the length PB. So we know that arc of contact EP, arc, the first part of arc of contact, arc EP is equal to line AP by cos xi, and similarly we can also derive for the second part, arc of contact, that arc, similarly we will have some name, let's say PF will be equal to line PB divided by cos xi. So if you sum those, you would do addition, then total path arc of contact is equal to path of contact, that is AP plus PB is equal to AB, that is total path of contact divided by cos xi. So the first part of arc of contact is known as the arc of approach. So during this time the engagement takes place, and the transmission is along the phase. They reach the central line at the pitch point, and after going through the pitch point, they are basically detaching from each other. So that second part is called arc of recess. So both of them, the definition is quite clear. Arc of approach is equal to length of path of approach, that is the distance AP from our figure. A is the first touching point, P is the pitch point, divided by cos xi, AP by cos xi, and the arc of recess is length of path of recess divided by cos xi. So in this case, this is PB by cos xi. This is AP by cos xi. And total arc of contact, length of arc of contact is equal to B by cos xi equal to path of contact by cos xi. I'll just write down the path of contact formula again here so that you can remember it. Just to recap it. So path of contact was it's a big formula, so I'll start writing here. RA square minus R square cos square xi minus R sin xi plus small RA square minus R square cos square xi minus small r sin xi. So this portion is recess, so the path of recess, and this portion is path of approach. The summation of both is the total path of contact. That divided by cos xi will give you the arc of contact. And from arc of contact, you can calculate the contact ratio, that is the number of teeth in engagement at any time instant, equal to arc of contact divided by circular pitch. So the distance between two teeth on a gear wheel. In reality, the contact ratio will not be a whole number, it will be some ratio, like 1.5, 2.5, 1.8. So we will make a whole number closest to that, and according to that, we will get the maximum and minimum pairs of teeth in contact are the nearest whole numbers above and below contact ratio. So if contact ratio is say 1.8, then maximum two teeth maximum can be in contact, or minimum at least at any time instant one teeth is in contact. So this kind of objective question can come. If the contact ratio is this much, what is the maximum number of teeth that can be in contact? So the next topic of interest is the interference in gears. So for that we have drawn a diagram here. This is, as you are aware, the O1 and O2 are centers of the wheel and pinion, and P is the pitch point. A is the point where the addendum circle of the wheel cuts the force line, and B is the point where the addendum circle of the pinion cuts the force line. Now, if no interference has to occur, then for no interference, the first and last points of contact must lie between the points of tangency. The points of tangency being I1 and I2 in this diagram. So these are the points where the normal is drawn from the center to the force line, and O2, I2 and O1, I1 define the base circles. So the point of contact, let's say B here, it should lie between I1 and I2. It should not cross the I2. Otherwise, it will be crossing the base circle profile, and when the leaving is occurring, let's say when the point is leaving, so the diagram is shown out like this. At the time of leaving, the point B is somewhat like this. So if it is touching the base circle of the wheel tooth, then if it is extending beyond this point, it will touch the profile at some other point. If the leaving is to occur such that the base circle, it touches the after the base circle, and this is point B, this is force line. So this is base circle. So base circle has generated the profile, involute profile for the wheel teeth, but the point B is still in contact with so the base circle can define only above it the involute profile. Below that the profile is not involute. What is interference? The contact point touching the non-involute portion of the teeth. That is called interference. We will derive a condition for non-interference, that it doesn't touch. So for that, the simple condition is that the B point should lie on the left hand side of I2. It should not cross the I2 and should not come here. If it comes here, then while the base circle has, this is a base circle, so it on the other side of the base circle also, it is still in contact after the base circle also. So base circle, this is a base circle, it will generate an involute profile like this, as shown you earlier. So when the teeth comes here, no longer the base circle remains valid. It can generate only up to this point. So this is the point I2. So we'll derive a condition for that. So the limiting case is when B lies on I2. B lies on I2 and A lies on I1. This is a limiting case, and if B lies on the other side of I2, then the interference is said to be occur. A and B are coming from addendum circles. So basically, it's the addendum value which determines point A and B. If this is a addendum circle of the wheel, if the addendum is a little bit more, then it will cut the force line at a point closer to I1. So the maximum, the interference condition will limit the maximum addendum for both wheel and pinion. So from the figure, the maximum addendum radius can be the distance O2 I1. When the distance of radius of addendum circle will be equal to O2 I1, then point A will lie on I1. So that is the limiting condition. After that, if you have further higher addendum, then the A will go on the left side of the I1 and interference will occur. So we will calculate distance O2 I1, and that is the maximum addendum radius that is allowed. So O2 I1 will be equal to, if you see the right angle triangle, O2 I2 I1, then O2 I1 will be equal to sum of, this is the right angle triangle, I2 is a normal on the force line, so I1 I2 square plus O2 I2 square, and the square root of that will be the hypotenuse, which is O2 I1. Hence O2 I1 is equal to O2 I2 square plus I1 I2 square. Now we know that O2 I2 is R cos xi. The O2 and I2, this is the radius of the wheel, pitch circle radius R, OP, O2P, and this is angle xi, the pressure angle. So from this triangle O2P I2, the O2 I2 is R cos xi. O2 I2 is R cos xi, I square R cos square, and I1 I2. I1 I2 can be broken into two parts, that is I1P and I2P. I1P from this triangle O1 I1P, I1P will be equal to small r, that is the circle radius of the pinion, sin xi, that is the I1P. And similarly I2P, Pi2 will be equal to r, capital R, sin xi from the triangle O2P I2. So we will substitute the values here. R sin phi plus capital R sin phi whole square. If to simplify this expression, this will be R square cos square xi plus R square sin square xi plus R square capital R square sin square xi plus 2r small r capital R sin square xi. So R square sin xi for R square cos square xi will be equal to R square. So hence this distance will be equal to R square plus 2 small r capital R sin square xi plus R square sin square xi. So this is the maximum O2 I1. This is maximum addendum circle radius for wheel. What will the maximum addendum for wheel? Max addendum for wheel will be addendum circle radius minus pitch circle radius, because addendum is defined as addendum circle minus pitch circle. So this quantity R square plus 2r small r capital R sin square xi plus R square sin square z minus R. R is pitch circle. Small r for pinion, capital R, xi is pressure angle. So maximum addendum for wheel, this is a condition, and if maximum addendum is less than this value, then interference will not occur. Interference, so no interference, addendum of wheel must be less than this value. From the geometry of the wheel and pinion, since pinion is assumed to be smaller, then always for the larger wheel the distance is lesser from the addendum circle to the pitch point. That means always the AP will be smaller than BP. BP will always be greater than AP. This distance AP will be smaller and PB will be much larger. This is just due to the fact that pinion is smaller and gear is large, wheel is larger. You can inverse it also, you will get the same thing, that the name A and B and R and capital R will change. But interference occurs first for bigger gear, that is wheel. So normally we will use the condition for that only. So that's why we have derived here the condition O2 I2, O2 I1, that is from the center of the wheel to the I1, the point on the base circle of pinion, that is the maximum addendum, and we are not deriving for the pinion because this is the limiting case, and this is the condition that we have derived.